Hello and welcome to Learn Data. It's great to have you on this channel. I'm Nilesh, and in this video we are going to continue to learn about pandas. In previous video we looked at the overall intuition and implementation of how wind type works with rolling function and how we can use methods such as boxcar, Gaussian and exponential to calculate rolling averages and rolling sums. In this video we'll go into much detail about the wind type Gaussian. We'll look at the intuition behind it, and we'll look at hands-on code to manually calculate the values for weights. This slide you probably remember from the previous video where we had a set of normalized weights that were calculated for a Gaussian kernel, that such as this one as shown in the formula below. And then based on these weights we modified the values in the dataset in a particular window to values such as shown here, which is the multiplication of the weights with the value. Then we add these values up to get the sum, which is the rolling mean. Now to calculate the weights itself, how do we do that? So as we see on this slide, we have set a window of 5, which is 5 data points we are going to look at, and then we set the standard deviation of the window to be 1. So if we look at these data points here, say from 0 to 4, we center them in this column A, and after we center them we then divide that by standard deviation. So we are right now working on this part of the equation. Once we do that, then it's time to square them, and after squaring we divide it by -1/2, so the exponential part of this. And once we have that, we exponentiate it right here to get these values, and we sum them. So what we have, if we look at just these values, those are the weights which are not normalized. Now once we divide each of these weights by the sum that's here, then we get the normalized weights, and these are exactly what we had in the previous slide and also in the previous video. So that's how the normalized weights are calculated. Now let's get into Jupyter notebook and look at how we can write a code in Python to create a Gaussian window. Then we'll also look at how to write a code to calculate the weights, calculate normalized weights, and based on those weights we'll also look at how to calculate the moving average and the moving sum. Then we'll also compute the same values using the dot rolling function with wind type as Gaussian, and put them in a data frame, see if they match, and also go ahead and create plots that will help us visualize the means that we calculate with the rolling function along with the original data in the background. So let's get into Jupyter notebook now. So here I've already created a new notebook and imported 5 libraries. One is NumPy, Pandas, Matplotlib. Those are the standards we regularly import. And in this video the new library is from SciPy we are importing signal, and from ipython.display we are importing clear output. This clear output will need that when we are creating plots, and the signal will need that to create the Gaussian window. And for data, we do not have any specific data. We'll create data frame as we go on in this particular video. So let's first go ahead and create the window, and we'll create the window directly using the command from SciPy. So the command is signal, which is what we have, signal.gaussian, and here we need to specify m, value of m, which is the number of data points. So here we'll use 20, and we need standard deviation. So let's say standard deviation of 5.0, and when we plot this, we should do that. Okay, when we plot this, we get these data points which are the weights. Now to create a plot, what we'll do is save this in a variable window and then create plt.plot window, and that's that will plot that particular data set. And we can also go ahead and add a title. This is Gaussian window, and here we have used a standard deviation of 5.0. Okay, and then we can also go ahead and add x label. So x-axis, and this is sample, and y-axis, so y label has amplitude. Now when we plot this, we see that this is a nice bell-shaped curve that we have created, and this is a window similar to what we have seen in the animated slides in the in earlier videos as well. So this is window that can be used now to get the rolling values either for mean or for the sum. Now for our case, what we are going to do is calculate. We are going to use the Gaussian, and we are going to do some manual calculations for this case. I'm going to create new cells, and to have consistency or create the same random values, I'm going to set the random seed to 0, and then create a DataFrame df. So pd.DataFrame, and this will have a column called y, and np.random.normal, and we'll set the size to 20 so that we have enough data points to see. And this is how the data frame looks like right now. Also, we can go ahead now and set the variable x to df.index. We'll be using df.index to calculate the weights as well, and y is equal to df.y. Finally, we also need to set the window to 5. We'll set the 5 data points, and then we'll set the sigma or standard deviation to 1. Now what we can do is calculate the arithmetic mean for comparison. So I'm going to save that in a variable mm, and that would be simple mean of the column y. So rolling, and here we specify the window is equal to window because we have a variable window up above, and we'll calculate the mean. So that's the normal mean that we have, and we'll compare that with the Gaussian mean that we are going to create now. So after that, the another point we need to do is initialize some variables that will store the Gaussian mean and Gaussian sum. So smooth y_smooth_mean and np.zeros, and here we are going to use df.y.shape and 0. I'm going to copy this entire line and create another one right below it for sum. So that's the y smooth mean and sum. Now let's start creating the code for calculating the weights. We know that we have 20 data points and we have 5 window size. So we'll write a for loop. So I in range df.y.shape, and what we are going to do is iterate through the entire data set with 5 window set, and I'm going to do window plus 1, and the reason for this you will notice later is to when we are going to add the R calculated values to the data frame that is up above, and because there will be NaNs in the first 4 rows, this will be used to adjust for that. And in the for loop, the first step we'll do is get values for a window. So whatever window we are in that iteration, we need to get that. So z is equal to df.y.iloc, and here we start from I, and then we go from I plus window. So those are the data points we really care about in that particular window that we are iterating through. And we'll set the x vals variable to z.index. Why z.index is because the index is nicely arranged from 0, 1, 2, 3, and it goes on sequentially, so it's easier to just use z.index. And we'll set the y underscore vals is equal to z, because it will have only those values from the column y which are within the window that we are currently working in that iteration. Next we will get the kernel weights, or just say the get weights. To get the weights for Gaussian, I'm going to create a variable xgr, and it's the same formula that we have seen previously, which is this one. I'm going to put that in the code form. So first is we need to subtract the x underscore vals minus np.mean x underscore vals. So first we get the difference, and then we are going to divide that by sigma. Once we have that, then comes the next step to square it, and once we square it, then is the next step to multiply that by minus 1 by 2, and once we have all of that done, then we need to exponentiate it. So we are going to use np.exp to get that part. So this way now we have this will give us xgr, which are the weights which are not normalized weights. These are just the raw weights. Now to get the normalized weights, what we are going to do is divide these existing weights by the sum of, or the total of, all the weights, which is this. So this would be our normalized weights. Okay, so good, we have 2 parts done. Next, what we need to do is multiply these weights with y. So as you see here in this slide, we have these weights now calculated, which is xg, and we are now going to work on this column. So to do that, so let's say multiply y with weights, normalized weights. Okay, or let's just say weights, because we are going to do both the cases. Y underscore smooth underscore mean, this is where we'll use the normalized weights, and we'll save we are going to save that in a specific location. So I'm going to add the index for that. So I plus window minus 1, and then this is np.sum and we are going to do the sum of y underscore vals into this is xg, and because that's the mean, I'm gonna copy this and paste it here. The next one is sum, and therefore here we are going to use the same thing, except here we are going to use the xgr. So this is using normalized weight, and this is using not normalized weights. Okay, so we are done with that part. Now the next part is plotting. So we are going to plot each curve that we create, so each window, and we'll see how the window moves through the entire data set. So to do that, let's use the command called clear output, and weight is equal to, this is what it will do, it will clear the output from one iteration, and we'll be able to plot a new plot in the same space in the second iteration. So plt.bar x comma y comma alpha is equal to, we'll set this to 0.25, and this is going to plot the values of x and y. So that's our raw data. Okay, and next we are going to plot the curve. So plt.plot, and here we are going to plot x vals, and next we are going to plot xg, which is the normalized weights that we are using, and let's color code it as orange. So this xg would look something similar to this that we have above, and after that you can go ahead and add a pause of 0.5. so what this will do is it will hold for that much time, and so that we can see the plot before it changes. And plt.show, this will then show the plot in the output. And after this, what we are also going to do is create additional plots, which would be the kind of the final plots we need to see, and those would come outside the for loop. So if we now just go ahead and run this, here we can see that this is the kernel we have created, a Gaussian kernel, and it's moving through the entire data set that we have, and in doing so it is calculating the moving averages, which are stored in the y underscore smooth underscore mean, and the sum is stored in y underscore smooth underscore sum. What we can do is create another plot. So clear underscore output, and again say weight is equal to true, and now we can create a new figure is equal to plt.figure, and fig size, let's set is to 10 by 5, maybe much larger than that, how about 20 by 5, so we can see everything clearly. And the first subplot that we'll have in row 1, column 2, 1, and here we have plt.bar x comma y comma alpha is equal to 0.25, and then we have plt.bar x comma y underscore smooth underscore mean, and alpha is equal to say 0.5, and color is equal to orange. And so that's one plot we have. And the next plot we can create is plt dot subplot 1 comma 2 comma 2, so second plot, and this again plt dot plot x. So this time we are not creating a bar plot, we are creating a line plot. Alpha is equal to 0.25, and it's the same data. color is equal to gray, so it stays in the background, and then we'll label this time as original data. So that's the original data. Then we have plt.plot, and we'll use the arithmetic mean that we calculated. Alpha is equal to 0.5, and color, we'll color this as maybe blue, and label this as the mean and just the regular mean. And finally we have plt.plot x comma y underscore smooth underscore mean, and here we are not going to use any alpha value, and use the color to orange, and again label this to Gaussian underscore mean. So this should create really nice plot, and finally we can ask it to show the legend. So plt.legend, that plt.show, and that should work just fine. So here, let's zoom in on this. Here we can see that the kernel, that's a nice visualization of what's actually happening in the rolling window. So you have this kernel that's moving through your data space and creating these new data points, which is the rolling average shown here in the orange. And here we can see that the rolling average again, which is the Gaussian mean, is shown in orange, and the regular mean is shown in blue. One couple of points to note here is that you can see that it has reduced noise, so fluctuations are reduced. So this value of -1 is not there, high value of 2 is not there. So the width along y-axis has reduced a lot in this case. If you have a lot number of data points, you'll probably be able to see more meaningful trends in the smooth data. Now before we end this video, just want to show you that what we calculated is correct, and to do that what we'll do is create a data frame, and we are going to go ahead and add all the values. So pandas underscore Gaussian underscore mean. So this column, what we'll do is we'll calculate the rolling mean using directly the rolling command. So rolling window is equal to window, and then win underscore type is equal to Gaussian, and finally after that we have mean, where standard deviation was 1.0 that we had set. And next let's add another column, which is the calculated Gaussian mean. This is what we have calculated in the code above, which is y underscore smooth underscore mean. And similar to this, we can also go ahead and create columns for the sum, because we have already went ahead and calculated the sum using the y underscore smooth underscore sum. So this is the sum, and here instead of mean we are just going to change that to sum. Now when we run this and look at the sum, we should get the values that match in both pandas method and what we calculated above. So this again, nice to see the kernel moving through and creating these updated moving averages. And this is the line plot on the right hand side. And let's look at the data frame. So here we have the rolling mean calculated using the rolling function with win underscore type, and it matches with the calculations that we have for xg using the weights xg that we manually calculated from the formula. So that's really nice. And then for the sum as well, the values that were calculated directly from Pandas using the win underscore type do match with what we calculated using the weights XGR in the code above. So that's awesome. I hope you learned the methodology behind how the rolling function works, how a kernel works, and how you can use a kernel along with rolling to get moving averages or moving sums, and kind of visualize it to appreciate how the smoothing process kind of changes the data, reduces the noise, etc. If you still have any questions, please let me know in the comments below. I'll also suggest reviewing this video and the previous video. That may help clarify some of the questions. And in the next video, we have the exact same approach, but we'll look at the exponential function to get the moving average and the moving sum. Thank you. Please like, share, and subscribe. I'll see you all in the next video.